In this example, we'll see how Dask and Coiled can help you scale geospatial analyses using libraries like Xarray. I have two different notebooks here. One is going to be on a very small data set, one's going to be a much larger data set. And we'll see how we sort of scale between those two spaces. So first, I've made a cluster. This is sitting in the cloud on US East 1, where my data happens to live. This cluster is relatively small. Coiled went off, it gathered all my libraries, it made a cluster, it provisioned that cluster, everything's running. That took about 1 minute and 18 seconds. So not immediate, but often fast enough that it's fine. And we're going to use a library called Xarray to load in a Xarray dataset. Xarray is a common storage technique. Let's connect up my dashboard here so we can see those lights going. Yeah, and so we've loaded in that Xarray data into lots of little NumPy chunks across my cluster that's living here. And yeah, and so that we can see, the dimensions, the variables we have access to, and we can go ahead and compute something. In this first example, we're just computing like a little visualization of a GIF. You see that's actually running on just this one machine to create the GIF, but the loading happened in parallel. And so what's nice about Xarray is that the API people use is pretty intuitive for their field. Xarray was made by a lot of people working on geospatial analyses. It's a very general purpose library. People use it in finance and in biomedical imaging and lots of other spaces. But the terminology used tends to be intuitive for the geospatial space pretty well. So here's a nice image of, I don't know, something. You probably know this better than I do if you're watching this video. This is a relatively small data set. Let's go off to a different, larger notebook. So I'm going to play with the same cluster. So I refer to this cluster by name, Xarray example, in both notebooks. And so it will be, it'll just pick up the same cluster. And let's go and in this other notebook, do this other analysis. Again, we're loading data from Xarray. We could also use the Xarray open_nf dataset function to load from NetCDF or HDF5 or other data sources. But in the cloud and geospatial processes, Xarray tends to be sort of dominant. This data set is larger, so we'll take a look at, I think it's ds.n bytes will tell us, hopefully, yeah. So there's this many bytes in this data set. Let's go and divide that by 1 billion to see how many gigabytes there are. And there's still plenty of gigabytes. This is how many terabytes are there. There's 500 terabytes in this data set. It's about a half petabyte data set. It's quite large. We're not going to look at all of that. We're just going to pull out a subset, so one variable and one time range. So this subset is just 6 terabytes, right? So it's chunked into 200 megabyte chunks. There's 30,000 chunks. We can go ahead and we'll just compute the average, the sort of spatial average. We'll get a time series out of this. So this is now sending up that computation, that sort of relatively simple averaging computation up to the cloud. And in a minute or in a few seconds, it'll start running on the dashboard. Let's make this dashboard a bit bigger so you can see the activity. I'm probably in the way here of the task stream. Yeah, so we're going to go chunk through that sort of large data set. We can process that 6 terabytes in small RAM. You can see memory is relatively constrained. But let's just scale up, rather than 10 machines, we'll get maybe 300 machines, just so things run a bit faster. I'm probably not going to finish this in a reasonable time. Okay, let me get this out of the way, so I'm sort of in the way here. So in about a minute, we're going to have many more machines, and our cluster will run a lot faster. We can get this result a lot faster. This is the value of the cloud, right? I can start on a small example with a few machines running relatively cheaply to process a small data set, like what we see here. Then when my analysis is ready to go off the big data set, I can go process, in this case, 6 terabytes, but I could process the whole half petabyte if I wanted to. I'm kind of vamping right now. I'm kind of waiting for these new machines to show up, which will be fun. We'll see going from 10 machines to 300, and we'll see these progress bars move a lot faster. Now is maybe a good time for me to mention a couple libraries we're using. So there's Xarray. It's again a very common library for multidimensional raster data. There's GeoPandas for more vector data. Let's go see if I'm doing. No. Oh, yeah, there we go. Our machines are coming up. Yeah, so we're seeing now this sort of task stream it's honestly now stalling because there's too many little things to visualize. But Dask is still running, just the visualizations are slow. And these progress bars are now moving fast, right? They're going to finish in less than a minute. This chart kind of stops making sense. I'm going to stop it just so things clean up a little bit. But yeah, so we're processing those 6 terabytes. Looks like we're processing maybe a terabyte every 5 to 10 seconds. We can go look at other charts if we wanted to. You know, what does workers network look like? You know, I suspect that we're mostly bound by our ability to read data. And it looks like we're getting, you know, decent read speeds. Yeah, it could be better, honestly. But great, so we got our results. Awesome. Let's go and compute average.compute. So we're gonna bring that result back down to local. Then we'll do plot. I think that might work. Yeah, and we see a nice little time series here. So let's go and smooth this out a little bit. Yeah, so there's our result. We processed 6 terabytes of data and got this plot. There are probably better plots you could do with this data. I don't know this space particularly well. You can do lots of things with Xarray. And then Dask and Coiled allow you to do those same things, but at much larger scale, right? People use Xarray all the time on a gigabyte of data. We're operating 6 terabytes of data. And the experience is mostly the same. The only thing we did is we just scaled up. We can, now that we're done, we can go and shut down our cluster. So we rented those machines for minutes, and that was actually probably cost us $1 or $2 to process those 6 terabytes. So that's it. Again, some things you can go look at. The Xarray documentation is excellent. People who use Xarray tend to be really happy. Other libraries like GeoPandas, also geospatially aware. And the Pangeo community is quite nice also. They've got a nice discourse forum where you can ask lots of questions. There are many people using Dask and Xarray at scale, and they're nice people, so it's a good place to go to. If you're used to the Pangeo stack, I'll also point to a video about how we sort of shifted away from we used to do things with Pangeo, or how I used to do things with Pangeo, and sort of the new sort of coiled way of doing things. I'll leave that hanging up now on the Xarray, on the YouTube links. So thanks again for your time. Cheers.